In this next part of section 4, we're going to just be looking at the special segments in a circle. So the last part, we were looking at angle measures formed. This part, we're looking at the relationships between the segment lengths. Now, if we have two chords that are completely enclosed inside of here, something interesting happens. And that is, if we look at these parts here, so like I take A and B and measure them, so I'm multiplying the red and green parts. They're on the same chord but different parts. And I'm also multiplying X and Y. So same chord with different parts. We're splitting them by where these two chords intersect. And if we look at that, notice that the product of A and B, so again, parts of the same chord, are giving us the same product. So no matter how I move these, A, X, Y, and B, they're all changing lengths. But as long as these are crossing, when we multiply, those are the same. Now, if we're looking outside of the circle, we're going to use a different rule here because of the way that my parts are coming together. Okay, so the way that we're doing it on this one, I'm still looking at my parts, but what I need is the outside part, so A and X are the outside part, and I'm multiplying it by the whole segment here, A plus B. So I'm adding that to get that whole length there, or X plus Y, that's the whole thing. So we're dealing with the part outside and multiplying it by the whole segment. So coming back to this theorem, the problem might look like this. We simply have the parts here. So if I'm looking for x, I know that x is going with 6, so I can say 6x equals, and then 3 and 4 are on the same line, so 3 times 4. So my 6x is equal to 12. It means dividing by 2 that x has to be 2. We can also use this in a case where we have part of an arc, just an arc, part of a circle, we don't know the rest of it. And if we wanted to find the radius of this circle, we could use this property. Now what I would do first of all, if I have this picture, I would draw it again looking at this. Now I know I have a perpendicular here, and we should have learned that perpendiculars, if we're dealing with a perpendicular bisector of a chord, it should pass through the center. So I know that this 48 is going to get split into two parts right down the middle, 24 and 24. So I'm looking for x, that goes with the 12. 12x is equal to 24 times 24. Now I'm going to take a little bit of a shortcut here. Rather than multiplying out that 24, I'm just going to divide both sides by 12. So we'll cancel this. Notice I can simplify this to just be 2 times 24. So I get x is equal to 48. Okay, we're not finished yet. We just found this x here, 48, but we were asked again to find the radius of this. We don't know where the middle, we don't know how to split the 48, but we do know that the whole diameter, that the diameter is equal to that part that we had, the 12, plus this x that we had, 48, which is giving us 60. So if we want the radius, that's going to be half of that 60 and give us 30. And the units that we have there are feet, so we will include that in our answer. So again, the next part is when we're meeting on the outside, we want the part outside and then multiply it by that whole segment. So we're going from here all the way across our circle A plus B, x, all the way across our circle x plus y. So looking at this picture, what we want to solve, we have 12 on the inside, 2 on the outside, 3 on the inside, but right here, we don't have any measurement here. That's what we're asked to find. We're asked to find RS. So I'm going to call that X. So we'll set this up. If we're using X first, the outside part would be X. The whole thing would be X plus 3. We'll set that equal to the other side where 2 is on the outside. And then we'll multiply that by the 2 plus 12. That's going to simplify to, this side is going to be x squared plus 3x. This side is going to give us 14 times 2, which is 28. And so we have x squared plus 3x minus 28 equal to 0. We'll solve it by factoring. X plus 7, x minus 4 equals 0, giving us x is negative 7 or 4. Now we should look at this. It doesn't make sense to have a length of negative 7 here, so we're going to use the 4, and our answer is just x equals 4, or really they asked for rs, so we'll answer this as rs equals 4. For the one on the bottom, we would set this up. Notice this time the x is on the inside, so when we set up that part of it, going with x, the 5 is on the outside. We'll multiply that by the whole thing, 5 plus x, and then down on the other part, the 7.5 is on the outside, so we'll start with that 7.5 times the whole thing, which would be the 7.5 plus 4.5. If we would simplify that, we would end up with 13. Okay, so the next one is dealing with a tangent line here. It's still the same basic idea. It's just with a tangent line, the picture might look a little bit different. And also when we think about taking the parts to the outside times the whole segment, well, the whole segment this time would just be the same thing. That's why we get x squared, because there's nothing on the inside to add to that. We can still follow the same basic principle, but we'll use x squared instead. So in this problem, we have x on the outside. So I'll start with x, and it's on a secant, so we'll multiply that by the whole thing, which would be the outside part plus the x plus 2, which is on the inside. That's going to be equal to the 4, which is on the outside, but it's a tangent line here, and so we're going to square that. We'll end up with 2x squared plus 2x minus 16 equals 0. And we could also divide everything by 2 to make this a little bit easier. But we won't be able to factor this, and so we're going to have to use the quadratic equation to do this. To find x, we're going to have to use negative b plus or minus the square root of b squared minus 4ac divided by 2a. Our b is 1, our a is 1, and our c is negative 8. And so this will simplify to a negative 1 plus or minus the square root of 33 divided by 2. We'll have to use our calculator to work that out, and rounding to the nearest tenth, that's going to be about negative 3.4 and 2.4. Again, it doesn't make sense to have a negative value for x, so we're only going to use the 2.4 as our answer.